A lot of other thoughts. Maybe I have some words at my last slide again. So let's get started. Welcome to my talk about PL SQL versus JavaScript in the Oracle database. My name is Philipp Salvisberg. I'm from Switzerland. The most important information here is the link on my blog. You should find it via Google. And the second most important stuff is a link to my GitHub where you find all the code snippets I'm showing here. So you should be fine there. Oh, Eric is better, huh? Welcome back. Good, huh? Okay, let's get started. First question is, why do we need code in the database? And that's a good one, and we had the talk before about Hibernate, and that could quite well fit herein. On the left side, we have a UI where we show a result in a graph, in a picture about the turnover over a certain time. On the right side, we have just a lot of data, let's assume. So at a certain point of time, you ask two questions. How many requests are necessary to the database, and how many response packages I get back to get this result? And the answer depends on whether you are going to suck out all the data out of the database and process it in the middle tier, or whether you are going to push your code to the database and execute it there. And of course, we are here a database-related community, and all of you know, hey, of course we are going to push the code into the database and process it there. But let me explain, it just happens by accident. So as a developer, and also I spend a lot of time in Java and JavaScript, as a developer I try to use APIs. And there is an API, for example, to get me all the orders of a certain time. And that's just one request and a large response message. And just assume, hey, bad luck, I do not get the information about the region there. So what I have another cool service already tested, etc. And I can ask the customer service, give me the region of the customer. And bad luck is we have a lot of customers and I have to do a lot of requests. And to be faster, I can do that stuff in parallel. How cool is that? And I'm hammering the database with all these requests to get all the data back. And what I have to do, I have to aggregate it somehow there. So that's the reality. That's just we try to reuse stuff. Sometimes it's good, sometimes not so. So obviously the better thing is to execute something like that, a SQL statement where can just get me the information I want, the region, the sales. In this case, I get just 3 rows back. It fits in a single TCP/IP package, so the best from a network performance point of view. Okay? And what is also good is not only I'm executing there, I'm using the database as a processing engine. And the database is super good in aggregating stuff. When we do that in the middle tier, it's, yeah, we have to develop it ourselves. It's not so good idea. So it has advantages from a performance point of view regarding the network, but it has also other advantages to push code there when you want to ensure that when you're querying data, you don't have to cleanse it when querying. So I don't have to auto-join everything and then to deal with region that does not exist or whatever. So I want to rely on the data to enable the database to get me the response as fast as possible. Okay, and that leads to basically 2 incentives I have to push code into the database. One is the performance, and one is the consistency, the quality of my data. So let's talk about the programming languages we have for that. So we have, Oracle is developed in C, and of course you can also write stored procedures in C, kind of. You can develop a library, push it somewhere on the database server, register that library, and then you can define an interface like I've done here, and then you can use it in your code. The disadvantage is I have to push something on the database server side, which becomes difficult in shared cloud environments. difficult, let's say impossible in dedicated environments. You have an idea. So what we have, what we use all, and what we like, most of us, is PL SQL. And here's a very simple one. And the unique feature of PL SQL is that I have static SQL. But what's the advantage of static SQL? The advantage is I get compile errors regarding the syntax and the semantics. The syntax, it's whether I do write here an update, and the semantics is it checks whether the table emp or the column, what is it, cell does exist. So I get that feedback immediately when I compile it. That's cool. And an additional advantage is it's not possible when you use static SQL to have SQL injection, by definition. You just have to look at your dynamic SQL, and if you don't have dynamic SQL, no SQL injection is possible. That's cool. There's another thing. As a side effect, since Oracle just stores the information in the dictionary, you get the information, oh, where is this emp table used? Even you get the information where the cell column is used. It's not really good exposed in the data dictionary, but it's there. Okay? We can also do stuff in PL SQL which is not related to data. So just some function. I have done here, probably you all know the Unix time. It's the time passed since the 1st January 1970, and I can calculate that in PL SQL. I've done that. But when I implement something like that, I have to look up, hey, is it seconds or is it milliseconds since the 1st January? How do I deal with time zones? And by the way, it's a bad idea to pass in a timestamp without time zone, but it makes the example much simpler. So just to have said that. And when I pass in a timestamp, what time zone is applied? How does the Unix time deal with leap seconds? How does it deal with the stuff that we have invented, daylight saving time, after the 1st January 1970? I have to look all the stuff up. It's quite easy in that case, but this code becomes the responsibility of my application. And I don't want to do that when something else exists. And that brings me to the next thing, the Java introduced in 8.1 as the big thing. And Java has a JDK, and in JDK it provides a lot of functionality. And one of the functionalities is that I can get just the Unix time as a function. Here we see it as get time. So I can use that. The syntax requires also that you have a wrapper. It's called the call specification, and I have to define, my input timestamp will be converted to Java SQL timestamp. I have a lot of options. I can convert it to date, to various types. And my result is a long, and this will be converted to a number. I have to define that. So that's Java. And in Java, the cool thing is that you can load jars into the database. And one of the craziest things I've done is loading Java drivers of other databases into the database. You can ask me in between sessions why. There was a reason, but what's a cool thing? There are 2 or 3 disadvantages with that approach. First one is I have to find a Java jar that is compatible with the version in the database. And the versions in the database are super old. Currently, that's JDK 8 or 11, and the current LTS version is 21. The one before was 17, and then it's 11. So 8 is really, really old, LTS perspective. And so when I load that jar in file, it's for sure, most probably, it's desupported. And most probably, it has a lot of vulnerabilities in which nobody will look at. So it's a bad idea to do that. Another thing is that a jar file is basically just a zip file from a format perspective. So we have a lot of files in there. So what happens is every single file will be loaded explicitly as an object. Everyone who has seen that the slash files there in the dictionary, you are going to pollute your data dictionary with tons of objects. This is not only slow to store, because there are some resolving activity there that is really, really slow to load such a jar file. So that's one disadvantage. Java is a full-fledged programming language. We have access to the file system, we have access to the network, and we have access to tons of other things which we have to control. So by default, all that stuff is disabled, and you have to figure out what you have to enable. So that's also not that easy. This brings me to JavaScript. And a lot of people ask, hey, why is Oracle choosing JavaScript as the first language? And I have several theories about that. One theory is JavaScript itself is a language introduced for the browser. So there is no part in it to access the file system. There is no part in it to access the network system. It makes it a very good candidate to put into the database because the language itself cannot do that. Everything is provided by the runtime engine underneath, for example, the browser, or for example, Node.js. Good. And when I look at this example introduced in 21.1c, it looks very much very similar to the DBMS SQL package. So what you do here is you open a context, and at the end you close a context, and here you are calling a JavaScript. There are several languages in the future available, and I pass here a constant that's defined here. And as the first thing here, I'm requiring some bindings. The bindings allow me to read input values, and the bindings allow me to provide the return value, the milliseconds, and that's basically my code I want to execute. So a lot of boilerplate code here. And of course, I also need here then these export things and these import things. The cool thing is I don't have to do the mapping of the data pipe anymore. I can, but there is a default behavior behind the scenes, so if the default is good, I can live with that. In 23c, finally, we got stored procedures, stored functions as JavaScript. The syntax is very similar to the one we've seen before to Java. It's really quite similar. So I have here a function to do ts value of, and I have to also to implement the wrapper or call specification, and I can map, as I said, the timestamp here to date. There are other options, I've mentioned it here. It can be a Oracle timestamp. What it's not possible anymore to map the return value, because, hey, whatever you do in JavaScript, the data type must be convertible at the end to number. If it's not possible, you get a runtime error. So it becomes also a bit easier there. But we can also do SQL in JavaScript. So yeah, we want to do that. Here's an example. And the interesting thing here is you don't need to import the Oracle driver, the one used in the database. It's already imported. And not that alone, there's also a global variable called session that contains the default connection within the database. So it makes it easier to read, but it makes it also easier to write 100% the same code outside of the database and inject the session variable at runtime so you can develop it outside. This is really a good idea, and we really should use this feature, even if it's not well documented in the current version. Okay? When we are using dynamic SQL, there are some disadvantages or some changes or different behavior to pure SQL. So it's dynamic, it's just a string, and we have runtime errors instead of compile errors. This has pros and cons, in fact. But we have also the risk of SQL injection. We have to check, are there really bind variables used? Nothing there it seems to be okay. In that case, SQL injection is not possible, but I have to check it somehow with tools or manually. And we have no information in the data dictionary about it. A major advantage of this approach is that I have access to the huge ecosystem of available JavaScript libraries. Who of you knows NPM? I guess some of you. There are tons of libraries there. You can just search by keywords of it and reuse that code. You see which version has which vulnerabilities, etc. This is really, really cool. So here's a URL I'm using here to get me just a single minimized file of a module. And I can use that with a script and directly load it into the database. I use a bit older syntax because SQL CL by default requires JDK 11. It does not come with a JavaScript engine for whatever reason, and therefore you are somehow stuck in it, or you use a GraalVM configured JDK with a newer library in there. And the advantage is when I load such a library into the database, even a large one, and I tried some large ones, it's there within a few seconds max. Basically, the network transportation time is what counts. It has to be that fast because this stuff is used in the browser as well. So this is really, really cool. And I just have a single object in the database. So compared to Java, this is super, super good. A disappointment is that I cannot manage all these versions within the database. So there's an additional parameter where I can pass in the version, but I'm controlled itself. So it would be nice to have something like, what versions of libraries have I installed, what are the vulnerabilities of these libraries, blah, 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 as I know it from other package managers. But that's version 1 in the database. I think that will improve in the future, and the product manager, Martin Bach, is aware of that one. So let's look at the sample. This validator has tons of validation functions in it, and one of them is to validate if an email format is valid or not. And there are two signatures. One is where I pass in just the email address, and there's a second signature where I can pass in a JSON variable. Yeah, you have to know that you have to map JSON to any. There are some things which are a bit strange, but you get around it. And this is necessary because there is no possibility right now to deal with the default values. You have to map them manually. I've added an additional syntax here where I do that by default, but I have to handle the code in the package body later. So I have to provide the wrapper in the package body later. But I want to ask another question or show you something else. Is it really necessary to provide a JSON as option as a wrapper in the database? And when you look at the next slide, that's a condensed version of the documentation. You see you pass in an object with a lot of options. And in JSON, you can skip one, you can change the order. These are the defaults. And the object you pass in will be merged with that one, and that's standard behavior. A lot of functions use that mechanism. That's okay in JavaScript, but is it okay in PL SQL? Do I really need everything? In my opinion, probably one configuration is good enough. Just don't map everything one-to-one. From my point of view, it's not always a good idea. So let's look at the implementation we have in the JavaScript area for MLE, for DBMS MLE to be precise, the dynamic variant. There's some new feature herein. It's now possible to import in dynamic script also my own third-party modules or other modules. This was not possible before. I can do that right now. The syntax is a bit special. I have to do that asynchronously, but that's not the problem of the MLE team. That's JavaScript syntax. You have to do it asynchronously. And when I do something like that, I have also to define an environment. And why do I need an environment? I don't have access to Filesystem, so my JavaScript environment has to read it from somewhere. It's in the database, and the link to know where to find this stuff is this environment. It looks like this. It's quite easy. You define the name, how to use it in the JavaScript code, how it is used, the name used in the Oracle dictionary. And you may ask, why do I need really more of them? It can be one use case. We have to find that out. We are on a journey to find out how to use that stuff. But one case, I can imagine you can handle different versions and easier to exchange that. Try one, change the environment, and see how it works. You can also define some compile options because the code in the database is compiled really first and then executed, and say whatever you want to configure there. Okay? Good. This is an overview of what we have right now. Languages, I categorize them in the first category, stuff you can do where you just need a connection, so where you really can push the complete code into the database. That's on the left side. And on the right side, where you have stored objects somehow. We have in C, PL SQL, Java with a JVM, and we have JavaScript, which is powered by GraalVM. Powered by GraalVM. Maybe you ask the question right now, how many JVMs do we have right now in the database? That would be a good question. And the first one is, it depends if you install the Java option. That's an option. You can deinstall it depending on the version. You have JDK 8 or JDK 11 right now in 23C. That's the one thing. You have or you have not. And the other thing is, for the support of JavaScript, they use the feature of native images. Who has heard of native images? Some of you. It's supposed to be super fast. You get just an executable. But you can also create the shared library. So based on the JDK and the JavaScript engine, they find out what they need at runtime, and they produce such a library. And it is about 200 megs of the size. And you have that in 23C onwards always in the database. That's not an option. It's enabled by default. The DBA cannot disable it. OK, at that point, when we talk about GraalVM and performance, we have to measure some things. And that's in that chapter. The first thing is, I always hear, but when I use that function the first time, how long does it take to get a response? So I did exactly this kind of tests, and I repeated the tests on several environments. I used the fastest environments I personally have at home to show you here the best of 3 attempts. So what is the first call after a shutdown of the database and the restart of the database? In PL SQL, it's 2 centiseconds. In Java, we know that it's just slow. Huh? It's no surprise. And when we look at the stuff here in JS, and this DJS is dynamic JavaScript, that's DBMS MLE, it's a bit slower than PL SQL, but hey, you won't notice it as a user for the first time. So well done, MLET, super good. Next thing is when I open a new session and someone else has done the restarting stuff first, how long does it take now? And we see it's even faster in PL SQL. Java is still slow. But when we look here in the JavaScript variants, these are good responses. Of course, they are a bit slower than PL SQL, but good enough, really. So this is not a problem anymore. Startup, first session, issue solved. Now it comes a bit, now we have another slide, yes, the memory usage. Yeah, the memory usage is probably not there where it should be. From my point of view, it's not a big problem if you have enough memory. When you don't have enough memory, and this can happen when you use the free version, it's limited to 2 gigabytes, so using more than 5 sessions in parallel is probably a problem. Huh? So maybe Oracle should consider to increase that, to push this functionality, and also to enable us using MLE in-memory feature in parallel on a free edition, so it won't work otherwise. But in real life, for Enterprise Edition, Standard Edition, memory is not a problem. You have connection pools from my point of view. It's not super good. The MLE team is really working to remove that part here. Here they cannot do a lot about it, but here to remove this part, to make it smaller, but it's not there. It's not a big issue. So the next thing is I want to run stuff 100,000 times. And it can easily happen that you're comparing apples with pears, huh? Not pears are really small, but yeah, they are also different. But I have to, you don't see that by the graphics. I have to do some explanations. The first thing is, I've run this toEpoch function, the one that converts the stuff to Unix time. And I don't use here milliseconds or seconds anymore. I use the normalized time just to make it easier to see the factor, how much slower it is. So when I compare PL SQL with Java, I see it's 64 times slower. And to be fair, and now this Apple peers thing comes in, I'm doing the loop in PL SQL and calling JavaScript function every time. So we have 100,000 times that context switch. But anyway, this is qualifying time. I just want to go on with some of the best ones, so it doesn't matter. The next one was a bit surprised, DBMS MLE. It was super slow. And I showed that slides to Martin Bach and the MLE team, and he suggested and said, yeah, maybe you should open the context and close open the context just once, use it 100,000 times, and close it at the end. Say, it's probably difficult to apply that in applications, but anyway, I've done that, and that's the result. So it's really better. It's similar to JavaScript. And then we have JavaScript stored function in that case, and also 100,000 time context switches, and it's 3 times slower. So this was just qualifying, as I said, because the next test I want to do is with SQL in it. So these ones in the middle didn't made it to the final race. So we are comparing PL SQL stored procedure and JavaScript stored procedure. And these are the results. So I've done here PL SQL 100,000 times with static SQL in it. And I thought, OK, to be fair, I should try it out with dynamic SQL, just to make it really comparable. And the next thing you see here, it's the result with the dynamic SQL, and it's 10% slower. So for all of us who say, yeah, we should really use dynamic SQL because statics is much, much faster. Yeah, it's faster, but much, it depends. Depends how you look at it. And then we have this JavaScript stuff here with 100,000 times context switches. And I thought, maybe it's a good idea to try it out when I do the loop in JavaScript itself, just to eliminate the context switch. And that's the last thing here with the JavaScript loop. And you see, the result is a bit disappointing. It's 7 times slower than PL SQL. And I haven't got the response yet back from the MLE team, if it is easy to solve or not. They're aware of the problem right now, not very happy with it, not happy that I'm going to demonstrate that stuff here. But it is how it is. I have some suspicions, maybe security is involved here. I have no idea. But security is just a word I use to go to my next slide here. And let's look at some security practices and how we handle exceptions in JavaScript. And we have here bind. We have here an example which I took out of the MLE documentation. It's the recommended way how you should make sure that your SQL is not vulnerable to SQL injection. And I simplified it. I moved out all this try-catch stuff out to make it simpler. So what this procedure does here is it creates a private temporary table. On the right side, it shows a variant how you could do that in PL SQL. I usually do a template function with some placeholder in it, and then I'm going to replace this placeholder, and I'm calling DBMS Assert to make sure that no SQL injection is possible. On the right side, on the left side, we see a two-step approach. The first, they recommend to call DBMS Assert in a separate call. Then I get this result back, and then I use that one in the in the template literal. And the cool thing in JavaScript is I can use this dollar and then put in here an expression in it, not only a variable, and that's really cool to write stuff. So this looks good. I like the lower part, but I don't like the upper part where I have to do a dedicated code. So I thought about how can I improve that one? And you know, we can use existing libraries, and there is a library that is called SQL Assert, and I just use that one, and then I have a much simpler code here. I just use the simple SQL name here, has the same functionality as within the database, and it's very terse. It looks nice, huh? So when I call it with a name which is not valid for a table name, with a minus, with a dash within, I get an error stack. That's expected that I get an error. I get a good error message also. There's an invalid SQL name, that's good enough for me. But I get also a lot of information where I said, hey, you should call DBMS error stack to get the full error message. And I look at the stack, really, is it not complete? And when I look at it and I see, in fact, this line here, this line 7, session execute is not reported here. There's no create temp table mod here in that stack. So I thought, okay, let's try that out. How complicated can that be to get the full error message? So I had to look up the documentation. On the right side, you see what you have to write. I looked up how this should look like to make it similar. And I expected to get a full error stack back. But no, I just get the missing one. So what you have to do is you have to merge this information in your head. So it's not at the beginning, at the end, it's somewhere in between. You merge it, and easy, right? So I very much agree here with John McEnroe. Huh? But you also have to know that was 1891. I watched that live, I can remember. Not that match, the final. And that's the year where he won, not only that match, but his first Wimbledon title. So it looks bad, but it's not mission critical. Huh? It's just some of the fun slides I had to write. Okay, the next thing is, that's really more important, this is development and tooling. Me as a Java developer, as a JavaScript developer, for me, tooling ecosystem is important. So what do we have in SQL and PL/SQL area? I guess the most of you in the room are familiar with the stuff on the left side. There are some tools which are also on the right side in the JavaScript area, but there are always plugins functionality which is dedicated either to general database logic or Oracle database logic. What's the difference between these two ecosystems? So from my point of view, I've also stressed this analogy with tennis again. In my opinion, on the right side, in the JavaScript side, we have the top 20 tennis players in the world. On the left side, we have good tennis players, but let's say below 300. I have no chance to beat one of them, but they are not near at that top. They cannot live with the prize money they earn as a top below 300 position. So that's the difference. And a lot of people won't agree with me, and I show two examples why this is awesome as you have in JavaScript. The first one is, remember these options I showed you for the email validator you had? In Visual Studio Code, you can click here after defining the first one, which is display name true, Control Top, and I get a list of other options that are available. The one I've selected is not listed here, and the one I'm with the cursor on it, I get so-called JavaScript doc information about it. This is really helpful when you're developing code. In PL/SQL, we don't have something like that, and we will never have. I just say it like that because I believe it. So that's one thing. The other thing is, you don't have to believe me. So that's another thing. So debugging in Visual Studio Code. What you do, you set somewhere a breakpoint, even on the library you are going to import, run your test, you stop there, You see at the world of all variables you have, you can drill down, you can apply functions on it. With IntelliSense, we've seen before, it's really, really cool to work with it. And let me say one thing. Debugger is not here just to debug code and find bugs. Debug is usually, I use 50% of my time to understand what the library does. I just do a breakpoint, say, hey, what am I going, what are they doing, and then I understand the code and can better use it. So that's the other thing. What do we have regarding the MLE in the Oracle database? We have a thing that is called post-execution debugger. So it's pretending to be a debugger, but without stopping at the code. So what you can do is, you can, instead of a breakpoint, you can set the debug point. It's very similar to a debugger. You say at which line you would like to stop, what variables you would like to see. You define it in JSON, so it's very modern. And you have the condition when it should stop. And then I can run that, and I get this information. You have also the option to show all variables. That's the other syntax here, and I get such an output. So basically, that's just the API the MLE provides for IDE developers. And the first IDE who uses that is not SQL Developer, but a sibling, Database Actions, or how Jeff Smith is calling it, SQL Developer Web. It's not the official name, but he would like to have it to be that one. So what we see here is the result of my debug points. And they are really, really nicely arranged. On the left side, I see all my results. I can choose the line. There's just one. And I see here such a debug point. So where would I have been stopped when it would be a debugger, and what would I see is presented quite well. That's OK. It's a bit cumbersome to define the call here in an asynchronous modus because it's not otherwise possible, and to define the input JSON. You have some templates to use, but it's not nice to work with it. OK, this brings me to the key messages and slowly to the end of this presentation. So when I compared PL/SQL and JavaScript, there are some pros, and obviously on the other side, the cons, and the most important one at the top. And the most important pros, in my point of view, is that we have tons of ready-to-use third-party libraries on NPM which we can include. It's not that we can load it into the database only. We can use the same library in the middle tier, in Node.js, for example, or we can use the same library when it doesn't have dependencies to the database also in the browser itself. So a validator could be used on every stage there. So this is really nice. Another pro is that the ecosystem is super good. We have tons of developers who know how to develop in JavaScript and so on. It's much more popular. We have every year we have a new ECMAScript version, which is the definition for JavaScript, and we have then followed implementations. The language becomes fast, better and better and better. On the pro on the PL/SQL side is it's much faster. And it's not just a small percentage. It's, as I measured it, it's 7 times. So the gap is really disappointing regarding GraalVM. And we have we have less risk of SQL injection, etc. But what I haven't mentioned here is that all data types are currently supported in PL/SQL. In JavaScript, there are some exceptions here. I guess long and long row will never be available, but they are currently working for 23.4 to provide support for XML type and object types. I don't know about the other tools, but for the other ones, we can assume they will be available when 23C is going live for Enterprise Edition. And one thing I left open is dynamic SQL versus static SQL. So I'm really in the camp of static programming languages. But dynamic languages have a lot of advantages. I just can load the JavaScript library into the database, and I don't have to care whether it contains stuff which will never be exposed by the wrapper. It can contain that stuff. I just put it there. It has an advantage to work that way. So I have to think about a bit more whether I like it or not. There are pros and cons. And yes, it is how it is. And another thing we have to think about is Tom Kyte was mentioned in the previous talk as well. He had this mantra, and in every book you find a version of it. It's different. It's not always the same one, but the principle, first SQL, then PL/SQL, then Java, then C. Is that still valid? And when you read it here, you should do it in a single SQL statement if at all possible. If at all possible. Just think about that. With SQL, which you can use nowadays. We have SQL with a with clause, which can provide PL/SQL code, which can call autonomous transactions, which can call JavaScript code. Is that still counting as SQL? It's just a SQL. So I think something is missing, like considering the technical depth. Is it really worth writing everything in a single SQL statement? Even if it is possible, it does not mean it is good. Huh? So that's one thing we should consider. I haven't found a good definition for that one, but that's an area where we have to think about. Another thing is JavaScript is missing. So I just first tried to position it, but I positioned it right now at the same level. Because from my point of view, you don't write the SQL application. You write an application in a programming language. So the SQL is either embedded, let's say, in PL/SQL or in another language. And depending where it is embedded already, it would make sense to put the code there, or write the code there. So I have to think about it, but on my point of view, JavaScript is becoming a good option. And this brings me to the last slide. And it's really a pity. It's really a pity the entrance song was not played. Huh? Because I like the song. And you remember when we were all kids, huh? I was not able to talk English. So we are just done something which sounded like English. And I loved this song as a kid. Huh? I loved this song. But I learned later about the lyrics. And I understood English, but I didn't understand what the meaning was. So Tom Henley in an interview once said, it was a journey from innocence to experience. And what he meant, according to another interview later, and by the way, Don Henley was the drummer and also the one who wrote the lyrics for that song and who sang it. And what he said in another interview was, he thought when he's going to produce his first album, after that he can go home and buy his parents a farm. He learned later on that you don't earn money with your first album, music album. That's not the way it is. But it's this naivety we have which pushes us forward, this curiosity to look at that stuff. And that's the point where I think it's matching. We are on a journey from innocence. We don't know how to use this stuff, and we have to learn it. And the only way to learn it is try to apply it. Try to apply it in your small applications. Try to apply it, for example, for those, this is a good example, use image, Oracle Multimedia was deprecated. Who has using it? One at least should have used it. It could be an option to use GIMP, which runs in the browser, and deploy it in the database. I've tested that one to deploy it in the database, to use it as a replacement. Sounds cool. Try these things out. However, I believe currently that it's much more efficient if you develop and test your MLE modules outside of the database. I've done a blog post. It's about 20 pages when you print it out, because I cannot fit it in this presentation. But when you go to my website, you can read about it, how to do that. You can test it, and just deploy your code into the database. And you can just use all these fantastic features of an IDE in JavaScript. And you have the fantastic performance, okay, 7 times slower than PL SQL, but you don't have the round trips in the database. So I think this might be a paradigm shift in developing database code. That's my current impression because I'm naive, you know? We will learn in the future. Maybe in 5 years' time, I will do another talk about the reality of the MLE. Thank you very much.